Okay, let's go ahead and work on 10.1, okay? So, this is hypothesis testing, and all you have to do in this section is answer what the hypothesis is. So, the first one says, a newsletter publisher believes that over 69% of their readership owns a Rolls Royce. Is there sufficient evidence at the 0.10 level to substantiate the publisher's claim? State the hypotheses. Okay. Since I'm not talking about means here, I know I'm going to use a P in my answer, okay? So, it believes that that over 69% of their readership owns a Rolls Royce. So, they want to test that. So, that's greater than. So, down here I'm going to put greater than 0.69, okay? I changed my percentage to a decimal. All right. So if they believe it's over that, then the mathematical opposite for the null hypothesis will be less than or equal to 0.69. Okay. So the steps again is I needed to do my null and my alternative. They are testing to see if the percentage is over 69. So that is my alternative hypothesis. My null is just the mathematical opposite of that, which is less than or equal to 0.69. All right, let's do another one. A newsletter publisher believes that 44% of its readership owns a laptop. Is there sufficient evidence at the 0.5 level to refute the claim? All right. So again, if you look here, I've still got another P because it's just a percentage, and down here I'm going to put the P again. All right. The publisher believes that 44% of the readership owns a laptop. Okay. Always and forever, that equal sign has to be in the null hypothesis. So I'm going to put this equal to 0.44. All right. So what does that make the alternative? That makes the alternative not equal to 0.44. How did I get that? Well, again, I know it looks like we're testing that he believes at 44%, but in the world of statistics, the null hypothesis always has the equal sign. So in that instance, you put the not equals in the alternative, and you see what it does based on the conclusion. Here we go. A director of research and development is testing a new drug. She wants to know if there's evidence at the 0.02 level that the drug stays in the system for more than 394 minutes. For a sample of 68 patients, the mean drug time that stayed in the system is 398 minutes. Assume the standard deviation is 21. State the hypotheses. Okay, that problem gave you a lot of information, but the one thing you really want to be looking at is, I'll show you here. So, because it's an average, I'm going to put my mu sign in there for both of them. First step, make that mu because you know it's an average. You don't see a percentage or anything like that. Okay, so this is greater than 394 minutes because that's what they believe. They think it stays in the system for more than that. So, the null hypothesis would be the mathematical opposite of that, so it would be less than or equal to 394. Again, look, my numbers are the exact same, and I didn't touch anything right here for the sample. I just needed the population mean to talk about in my hypotheses. Okay, let's keep going further down, and this will be the last one for 10.1. The director of research and development is testing a new drug. She wants to know if there's evidence at the 0.05 level that the drug stays in the system for less than 378 minutes. A sample of 90 patients with a mean time of drug staying in the system was 372. Assume the standard deviation known is 22. State the hypotheses. Okay, again, this is an average, so I'm going to put my mu's in there. Okay, all right, my next step is to figure out what I'm looking for. And for this one, it's for less than this. Okay, so I'm going to highlight that. So that means my alternative is going to be the mean is going to be less than 378. So what does that make my null? The mathematical opposite, which is, if I go back and insert it, greater than or equal to, okay? And you'll see this on Hawks on the keyboard. You can use these symbols. So this hypothesis, the null is the mean is greater than or equal to 378. The alternative is the mean is less than 378. I hope this helped. Thanks.